I'll be talking today about coroutines for JVM and Android. I was asked if I could talk about some modern Android development skills, and I think coroutines are very topic. So further delay, let's go. Super shortly about me, I'm an Android and a Kotlin developer. So I've been doing for the last 12 years Android development, the last years with Kotlin. And for the last 3 years, I've been focusing a lot on Kotlin for backend. I'm a member of the Google Developer Expert Program, and this is my Twitter handle if you want to follow. Sometimes I post interesting stuff, most of the time not. Well, coroutines. If you're Android developers, you've very likely heard about the word coroutines before. This is not a paradigm that has come with from JetBrains for Kotlin. It's something that have existed for a while. This is the, if you go to the, I believe this is Wikipedia, this is the definition of what is a coroutine, and it's a computer program to generalize subroutines for multitasking, allowing execution of to be suspended and resumed. This will be a key that we will see later on the coroutines. We are able to suspend the execution of a flow and then to resume it when this flow has finished. Why do we want to use coroutines? So let's take a look at this block of code here. We're trying to fetch some user data. When this user data has been fetched from our API, we would like to assign to the text view the name of the user. If this would be an offline meetup, I'll give you a few seconds so you can think about what's going to happen if we execute this piece of code. But I'll give you anyway a couple of seconds, try to see if there would be any problem happening here. Yeah, in Android, we'll get something like network on main thread exception because we can't execute network requests on the main thread. So in order to do that, we could have something like this from here. We could have a thread where we execute our block of code and then we update our text view or our UI component. Do you think this will have any trouble or this would create any problem? We have also a few seconds to think about this. Yeah, we have the call from another thread, blah, 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 exception, because we can't update the UI if we're doing it from a different thread. So, well, we can start using callbacks, right? We can fetch the user data. When this is ready, we came back to the original point of call, and then we try to update our UI. Is this a sustainable option when we're developing with Android? So the problem here is that we will be leaking callbacks all the time. In Android, we have we have fragments, activities, we have a life cycle, and if a network request is happening while the fragment disappears, bam, tries to go back, there is no fragment alive, and then we have this leaked, and this leads to a bad user experience. So there is also this callback hell when we start using callbacks, callback, calling another callback, etc., and the code becomes right there and maintainable. So we could start subscribing our callbacks to some sort of subscriptions and canceling them when our fragment gets canceled or our activity, etc. And the problem with this is that we will end up with a lot of cancellations, and this can be like a real code. Yeah, of course, we have you might say we have also like composite subscriptions. We do have them, but then we start the solution start getting more complex. We need to start adding those libraries, etc. So Google or Android tried to solve this problem in the past with the async tasks, which are deprecated, happily deprecated since some time, where we execute something on background, and we had like pre and post execute method to update our UI or collect the data from wherever. RxJava has been solving this problem for a while. This is how typically the RxJava for the proposed code would look like. We would have our function fetch user that returns an observable with a generic type user. And we would add this to the auto-disposable, to our Android lifecycle. We would subscribe there, and then we will update our the text on our screen. We also have LiveData, which it's similar, right? We have our LiveData, connect to observing or the lifecycle, and then when things happen, we just update our UI. Let's say that we have these three solutions at the moment. LiveData using observable data holders, and RxJava using a combination of observable, schedulers, and observers. and then coroutines that are using suspendable computations. Why do we need so many solutions? Which ones should we be using, etc.? So the thing with LiveData is that it's not fully complete, only supports the main thread. And RxJava is complete, but it's easy to misuse. It can feel like an overkill sometimes. Why am I using this huge library that includes so many things? And it has a learning curve at this rather extent. Coroutines are simplified, comprehensive, and robust. Of course, everybody says, my software is simplified, comprehensive, and robust. Is this true in the case of the coroutines? I think so. They also have first-class support from Google and Jetpack. But let's see with some examples if they're what they claim to be, and you will be able to take your own conclusions. So until now, in a nutshell, coroutines simplify async code by replacing callbacks. Let's take a look at this blocking piece of code. We will have a function called loadUser that makes a call to an API, and when the data is back from the API, we just display it on the screen. This would block our UI, right? How does this work? We call the fetch user, then we have those onDraw methods. Every time the UI tries to update on Android, the onDraw method gets called, but in this case, we can't call it because this call is blocking the UI, and then we show it on the screen. This has the problem that, of course, the phone becomes doesn't respond to any sort of user input. If it stays like that for more than 10 seconds, we get the ANR, out of application not responding, and that's a bad user experience. Let's take a look at this asynchronous piece of code. Load user is the same thing. It's just that where API calls, and there is a callback that will display the user when the API call has finalized. In this case, fetch user starts. We can happily draw our screen and keep updating our frames. And when it's ready, bam, we just saw the result of the screen. So this is how a coroutine would look like. See that essentially this is the same as the blocking piece of code. We just have added the suspend keyword in front of the function. And this, conceptually, it works like this. We need to suspend the function. We execute the blocking call, the API call. And when it's ready, we just resume it without blocking any UI. So suspend and resume replace the callbacks. If you're more interested in knowing what happens under the hood, this suspend keyword, what does is creates a listener that is passed to the function, which is an object of type continuation with some data. So if you're more interested into the technical details of this continuation object, this call from here, you'll be able to find it on Google, Kotlin 2017, Coroutines on GVM by Raman Elizarov, goes very, very deep technically. I'll not go that deep. I want to stay more at the Android high level, but essentially you can imagine the continuation object tries to execute the blocking call, and when it's ready, call resume internally. So let's go back. If we compare the coroutines, suspend in front of the function name, asynchronous is using a callback. So we replace callback with suspend keyword. Correct. This is how it would look. So we have the suspend keyword, and one interesting thing that we'll see later are the dispatchers. In Android, we can have different. We want to call things on the main thread, sometimes input, output, etc. We support this in coroutines by the use of dispatchers. In this case, our function fetch users will call with context specifying the dispatcher. We will have our blocking call inside the with context, and this will be able to execute on any particular dispatcher that we specified. Which dispatchers we do have on coroutines? So we have the default one, IO, and main. Default is the CPU. This should be used for operations that are intense in terms of computations. Let's say we need to take an image and analyze it. We need to do some operations over a big matrix, etc. So let's gonna do that on CPU. IO, input-output operations. Anything that has to see with writing on the disk or making an API call to our server should go on with an IO dispatcher. And main is the main thread on Android. That's easy. So, as mentioned, with context, our blocking call inside. Now, let's going to see a bit under the hood how this suspend function will work. We know that every function, we have a thread and a stack for the main thread, and essentially we stack there every function that we're calling. We store information about the variables, etc. So the execution of the program can go through. How does our program works as soon as we see that there is going to be a suspend function? Well, we evaluate and we see, well, there is a suspend. So let's gonna put on the stack a marker specifying that we just reached a suspend function. This is a suspend marker. Everything above is gonna be a coroutine, and everything under is our function. So we keep analyzing. Load user. Well, then let's gonna stack this here. Then we will stack as well our blocking call, fetch user, and we will start executing that. So sorry, I think I went too fast. Yeah. So, well, this keeps executing, right? We make the call to our API, our server, we fetch the user, and as soon as we start getting the information, then we start getting the result of those functions. We will get a fetch user, good, we get a user that is there, then we consume our function load user, and we resume the function at the point we left it. Summarizing until now. Coroutines replace callbacks, and they provide main thread safety, which is important in the case of Android. Now, we've seen the with context building block, but we have a few more. So with context have this peculiarity. It returns a result, and if there is an uncapped, it says in the application crashes. We also have launch and async. Launch is returns a job, is of type fire and forget, and if there is any exception that is not handled, the application will crash. And async is returns a deferred or a non-flocking future, the promise of having a result at some moment. If there is an exception happening that we are not handling, it will come on the deferred object, so it's a bit more convenient to handle it. We'll see as well the coroutine context that we have. So similarly to the previous dispatchers, here we have a UI that dispatches the execution into the Android main thread. The common pool does it into the background, and unconfined that does it into the current thread. This is useful for testing, among other things. So let's gonna start diving a bit more into coroutines, operators, and functions. So we have launch. First, let's gonna create a couple of coroutine contexts, one for the UI and another one for the background. So we'll essentially just define them like this: UI context and background context. And let's take a look at this piece of code, the most typical thing we can have on Android, right? We want to load some data, so we show the loading indicator. We fetch data from somewhere, show the data, and hide the loading indicator. So if we add after our function the launch, specifying the UI context, that's gonna launch our coroutine, and it will do it on the dispatcher UI context. So here we see that the result, which is the UI call, very likely, or taking the data from our database that we're doing, is using thaw with context on the background context. And that's interesting because we can execute this on the background context, so we are not blocking the UI, but then we can, with launch on the UI context, update the UI. So everything works. Android is happy. We are not making any network requests from the main thread, and we're updating the UI context from the UI thread. We can do a lot of things. We can launch two tasks sequentially. For instance, this piece of code, let's take a look at the relevant part. We could start a result 1 and then a result 2, both with context, and that essentially makes the first one start, and afterwards the second request start. We can launch it in parallel. So in this case, see that we are calling the await function, and we make two coroutines start at the same time. We can also, Kotlin is very idiomatic, and we have a lot of ways of doing things that result very comfortable for the developer. So in this case, we could create a list of async functions, and then with await all, we will start all of them in parallel. Timeout, very important if we're having network requests, right? So if our backend is not working, we just want to time out and handle the error. So with timeout or null, it will start the task with the unit of time that we specified. Cancel them, very important. If for any reason our screen is changing, we are moving between different fragments, we would like to cancel our active coroutine. Well, as mentioned, when we use launch, the function will be returning a job. So in this case, let's see this example. We have our function load data. We will have on next click, when we click on one button, for example, the result of load data will go into an object of type job. And when we click on back, or something happens, or the fragment gets destroyed or gets reclaimed by the JVM, we could just cancel the job. So the coroutine stops and we avoid memory leaks. Job has a lot of attributes. We can check if it's active, if it's canceled, if it has been canceled before, if it's complete, if it has any children, etc. Invoke on completion, this other thing, we can concatenate jobs or anything. Error handling. Of course, we can do try catch. So if that's the old-fashioned way, if something happens, just catch it and print it on the screen or do whatever you want. We can store it inside a deferred object, as we said. So our previous example, async, trying to do some operation and displaying it. So in this case, we could have our function load data assigned to a job, and we could invoke on completion. If there is a throwable return, then we can just handle it. We could use the coroutine exception handler from Coroutines. Essentially, we would launch the function specifying the context and the exception handler. And inside the exception handler, we can just define any, how do we want to deal with this exception. We can return null if exception. So we could catch if something, you can see here that this extension function awaits safe. If something happens, print the stack trace and return a null instead. So we will handle it like this. We will try to execute our coroutine, assign it to a result. If this is null, it has been a success. Or sorry, if this is null, it has been a failure. Otherwise, it's a success and we can access it. We can return a generic. So here, actually, you can see that we have this data class result that can be either a success or an exception. We could use a seal class for this as well if we want to. And if there is an exception happening, the success, that means our generic type will be null, and we will instead have an exception of failure. So when we're handling this, if success is different of null, that means that we have a success. Otherwise, we can directly handle the exception. Very convenient. Testing. Of course, we want to test our coroutines. So let's take a look at this presenter. Essentially, looks like any presenter. We have a function, and we will be passing our context as an argument. We can just use our JUnit or framework of choice for testing. In this case, we will do our function load data that is on our presenter, and then we could use Mockito or anything to verify that things are happening on the screen or the presenter is providing us some data, etc. See on the presenter that we are initializing it with unconfined, which refers to the current thread. That's how tests are done. They should specify the unconfined background dispatcher. Is this replacing RxJava? Well, I don't think so. But of course, it's a very complex question and with many different factors to weight. There are a few analogies, such as subscribe on in RxJava will be our initial context, observe on will be our with context. Disposable would be more or less like jobs. But yeah, like in any project, the answer is never a categorical yes or no. Unless the question is if you should use a syntax, then it's a categorical no. But you need to check, what are my resources? How is my team? What do I need to deliver? Do we have, it's hardly always a question that can be, or an answer that can be universal for anything. So you need to take a few things into consideration. A few more things. So Retrofit now supports coroutines out of the box. This is how we had to use it before. Our retrofit interface has a function. We would need to return our response on a deferred object, but since 2.6.0, I think, we just need to specify our retrofit interface with suspend, and then automatically becomes a coroutine. Room also has support for coroutines. We just need to specify on our function suspend, and Room will be automatically using coroutines. And they will have support for for essentially transactions and everything. Here we can see a transaction that is deleting a user and then inserting it. And then we see that, we will have our delete function, our insert function, and the suspend keyword on the transaction. So that makes sure that both the insert and delete operation are being executed on a coroutine. And yeah, so in this case, when we have our database in room, we would make with transaction, and then we can specify all our suspending functions inside it. Testing, super easy to test also with room. We just need to use this run blocking function from here, and we will be testing our DAOs or our functionality. To this, regarding this theme of run blocking. So run blocking is a function that runs interruptively until it has been completed. And on the documentation, it says that should not be used from a coroutine, but it's actually code examples from Google. So I would say probably running test is okay, right? Because you're not, I mean, if you block the monkey runner or your CI while a text is executing, it's probably fine and acceptable. But definitely not for real users. Serving and coroutines. I found this on Twitter some time ago, and I was not able to trace it back to the author. If I recall it right, that was about 1 year ago. Things might have changed since then, but you can see that most of the people was not actually using coroutines. Since all the support Google is getting is providing coroutines, I believe those numbers are increasing, but the reality is that in the real world, there is legacy code. We can just update to the latest version as much as we want. I can imagine that more people are using them, but I would be surprised if it's a majority of the software developers. Are you interested in coroutines, and would you like to move forward? What can you do from now? My ideas, if it's a greenfield project, you should probably go with coroutines, especially since we know that Google is going Kotlin first on Android mobile development, and well, everything is getting Kotlin priority. Coroutines are now heavily supported, so using something different would probably not make a lot of sense. But again, no universal answers. You have an existing project. Do they suit you? Can you refactor? Do you even have code in Kotlin? Do you have time? Would you try to do this on small sections, etc.? Those are very personal questions. Some further resources. Of course, coroutines, they have their guide from JetBrains. You can see here, very comprehensive. I think it's very clear and up to date. We should not forget that Kotlin and the coroutines are open source. So if you came to this link, you'll be able to see how they're implemented, pull requests or issues that are open, etc. The Kotlin Slack, if you're not there yet, is a fantastic place to be. A lot of people from Google and JetBrains supporting you and answering questions that you might have. If you allow me some spam, Kotlin Weekly's mailing list that I handle, I send an issue on Sundays. And there is a lot of coroutine articles going on, as well as Compose at the moment. I think it's a very good way to stay up to date. And this code lab from Google explains you how to start using Kotlin coroutines. So I can recommend it. It takes a few hours to finish it, and you'll get a really nice grasp of how they work. Couple of things more. If you don't know this repo, Android Architecture Blueprints, you'll be able to reach it from Google. And well, it essentially showcases different architectural approaches to work with Android apps and develop an Android software. And they're using a lot of coroutines, and you can see how they work on a real app. And last but not least, if you happen to be stuck with RxJava, if you're planning the migration from here, Chris Baines from Google wrote an article 3 years ago, which is an eternity in terms of software development, but there are a few things that are still relevant. So, I mean, RxJava, it's still an up-to-date software, but if your situation is being on the RxJava world and wanting to jump into Kotlin, I think this is a good place to take a look. So, well, that has been everything. You've been a fantastic public, and I hope that you've learned something new today. If that's the case, I will be super happy. Now, if you have any questions and I can support you with them, will be also a pleasure to
All right, thank you, Enrique, for the talk. I think I've learned so much about coroutines. My team at work is also trying to introduce coroutines, but slowly, because we are majority RxJava code base.
Yeah, I can imagine, right? And sometimes code bases are huge, so you just don't have the luxury of saying, "Hey, let's gonna, I don't know, put everybody to work here 1 month to migrate the code and stop doing bug fixing and new features." So you always need to see on the, on your life and your scenario how it works and how to apply it.
Exactly. I think that makes a lot of sense. We have one question here by one log. Is asking if there's any coroutines related method of video rendering in Android.
I'm not really aware that there is something so specific. Not really sure. If you ask me how to be rendering all videos UI, so I guess you should start probably working on. You should either check UI, or I don't know if you want to pre-render the video. You might need to use the CPU dispatcher instead of the main one. Yeah, that would be my two first guesses. If there is something so specific for video rendering, I'm not really aware.
If I may add, I think for video rendering in Android, we usually just delegate it to a video player like XO player, for example, and usually they'll handle all the loading of the videos in the background. So we don't really have to use coroutines for that. We just need to pass in the URL for the player. Yeah.
What about coroutine flows? Well, flows are ways to handle all the results from the coroutines, and well, we're talking about call flows, and it's a very nice companion for Kotlin coroutines. And I think naturally, as you use coroutine, I think probably it's a good idea to mention in the same presentation next time. So so I think if you're using coroutines, sooner than later you'll jump into Flow. They essentially help you to deal with all the result and the stream of data that is coming from the coroutine. If you want to combine them between the different flows, or similar to the streams in RxJava.